Va bene, l'introduzione non farà parte. So I have to remind everyone that the meeting is recorded, but not the participant list nor anything on chat. I also remind to please put your question in chat, and at the end of the meeting, we will answer them, either Elena or I will make the questions. So now, without further ado, I would like to introduce Dr. Elena Gissi.
Okay, thanks, Alessandra. So I'm going to share my screen. So now you should see my screen. Okay. So I was invited today to give a talk about my research path and that brought me to the Marie Curie fellowship that I just started at the CNR ISMAR. So I will specifically focus on I have worked on addressing conservation with marine spatial planning in the age of climate change. So I will start introducing the problem of conservation in sustainable blue growth, producing cases and about the opportunity of working and given by the ecosystem-based marine spatial planning. Then I will point out the second challenge introduced by climate change in MSP for blue growth and how MSP can contribute to adaptation and mitigation of climate change, specifically by managing the combined effect of climate change and other local human stressors. And then I will focus on the perspective of my research with Marie Curie. The recent policies, new policies about sustainable blue growth has apparently shifted the attention from conservation to sustainable blue growth, to sustainable development. And this can be risky if we don't include properly conservation within sustainable blue growth, because the sea is already intensively used and exploited, and identifying MSP and sustainable blue growth can potentially cause an increase in harms to the marine environment if it's not properly managed. They are not properly managed. So the first challenge that we are running into is how do we support the sustainable blue growth, and how do we effectively include the conservation while increasing and supporting blue growth. So we have an opportunity which comes from ecosystem-based marine spatial planning, which is composed of two parts: ecosystem-based approach, which is the first one, and MSP, which is I will briefly call it MSP, marine spatial planning. So ecosystem-based management is an integrated approach to management that considers the entire ecosystems, including humans, and the goal is to keep and to maintain ecosystems in an healthy, productive, and resilient condition so that they can provide multiple ecosystem services. EBM is different from other approaches because it considers multiple uses at once. So it is not focused on a single species or a single sector management. And this is very important because it entails a series of considerations, starting from that. MSP, so marine or maritime spatial planning, as is called under the European Union framework, is envisaged as a tool to operationalize ecosystem-based management, and specifically by the European Commission is the tool to support sustainable development, so sustainable blue growth in European marine waters. But what is MSP? MSP is generally defined as a public process of analyzing and allocating the spatial and temporal distribution of human activities in marine areas to achieve the ecological, economic, and social objectives. But what is this about? What is MSP? How does it work? So I just provide you a brief, simple example, which is a very trivial one, but I'm sure that you will keep in mind it. So imagine that you have to move in a new room, in a new apartment, and you need to furnish your room. So how are you going to do that? So first, for sure, you will discuss and negotiate with whoever is your partner and multiple users of the room about arranging the furniture so that you will achieve your multiple priorities and benefits. For instance, if you're smart working, or if you want to relax, or if you play drums, or whatever is the uses that you want to allocate in your room. And of course, you will arrange furniture considering the characteristics and the constraints of the setting, meaning the lighting of the room, or the position of the heating, or the cable jacks. And of course, you will arrange your room so to keep to support the well-being of all the users of the room, but also to keep the room in an healthy condition. So you will plan a configuration of your furniture and a series of management actions, for instance, to tidy up your room, and you will consider allocating all the uses in the room. So ocean planning, and specifically MSP, is not so different from what I showed, but at a different scale, meaning that our room is our ocean, our common ocean, and the goals that we need to achieve are the Sustainable Development Goals launched by the United Nations. And MSP works to allocate uses in space and time, considering potential interactions between uses and between uses and environments, so to keep potential negative effects of uses under a certain limits. So the plan will look like a configuration of potential vocations at sea of different uses, controlling that the combination of potential negative effects are beyond a certain limit. So the European Framework Directive on Maritime Spatial Planning, it was launched in 2014, and the Maritime Spatial Plans are expected by March 31st of this year. So member states are called to produce their plans in the marine waters. And this is a special and important aspect to be stressed, because the MSP process is a process of national competence on the entire marine waters of member states. So it implies a specific scale of analysis, which is the scale of the exclusive economic zones and the territorial waters. For instance, Italy will have 3 plans, one for the Adriatic, one for the Ionian, and one for the Tyrrhenian Sea. So how do we address conservation with ecosystem-based MSP? We can, of course, balance socioeconomic and conservation objectives, as the definition implies of MSP. We can make space for new marine protected areas while allocating usage at sea, so to achieve the 30% conservation target that has been recently proposed. We can control and manage the potential negative effects of human uses on the marine environment while allocating uses in space and time. And of course, we need to understand the cause-effect relationships that drive changes in the marine environment to act on the drivers and on the causes of these changes. In my research, what I tried to answer is to inform these decisions by producing the relevant ecological knowledge that is needed to inform ecosystem-based MSP. Specifically, this ecological knowledge answers and needs to answer to the specific problems that MSP is asked to answer to. So I will illustrate this assumption with some cases from my research, and you will find more in my publications. So the first case is related to addressing transboundary conservation challenges through marine spatial prioritization, which is a collaborative effort that I led in collaboration with CNR ISMAR and with the University of Queensland in Australia. In the Adriatic and Ionian region, the Adriatic and Ionian region is a strategic area for sustainable blue growth. And the European Commission launched the European macro-regional strategies to support blue growth in the area. So there are six countries, actually seven if we include Bosnia and Herzegovina, seven countries sharing resources and coordinating this path towards sustainable blue growth. But on the other hand, the Adriatic and Ionian region is a complex environment that shares marine resources. So blue growth necessarily needs to consider and to be achieved by considering also the achievement of conservation outcomes, such as the achievement of good environmental status. So in this study, what we aimed at was to illustrate the value of using spatial prioritization to as a mechanism to address complex conservation challenges. Because the problem here is, how do we set the 30% target of conservation in this region, which has a specific complexity in biodiversity features, in environmental dynamics, and so on. So we use the decision support tool Maxon to examine the target setting strategies for biodiversity conservation along the Adriatic and Ionian region. And we evaluated the impact of conservation plans on countries and on different maritime industries operating in the region. So our target was to achieve the 30% targets on 70 conservation features that we were able to, that were habitat of priority habitat for conservation of priority species and so on, considering 6 countries and the distribution of these on 6 countries and on 14 maritime industries. So Maxon is a tool that works by, that identifies priority areas for conservation by meeting predefined conservation targets and minimizing socioeconomic costs. So we ran a scenario analysis under 2 different hypotheses. The first one was about setting the priority areas conservation at regional level or a country level. So considering if each country would achieve the 30% of conservation in their waters. And the second hypothesis was about considering the cost for negotiating conservation. And for this, we used a proxy about the density of uses of the 14 uses in the region. So we arrived to 4 scenarios by coupling these 2 hypotheses, and we assessed the trade-offs between conservation and the influences, and so the equality between countries and economically important sectors. So as the result, we arrived to identify priority areas for conservation at the Adriatic and Ionian region under 4 scenarios. And specifically, we assessed that the most efficient scenario planning scenario was the scenario that considered setting the targets at the regional level, so not per country, and including costs for conservation. And this is very important because in this case, we identified transboundary area of conservation that need to be prioritized to support the biodiversity conservation in the region. And this is also to showcase the fact that countries can start from these specific problems. So we dismantled the complex problem in sub-problems, so to allow countries to start the negotiating among these specifically transboundary areas of conservation. The other aspect is that behind our model made some hypotheses about maritime industries, and this hypothesis in a way facilitated or advantages some sectors against others. And these hypotheses and these trade-offs needs to be explicit if we want truly to achieve economic, social, and sustainable objectives at once. The second case that I want to show is another study, again in collaboration with the CNR ISMAR, and it was related to modeling cumulative impacts within the first test of MSP in the Mediterranean with the project Adriplan, again in the Adriatic and Ionian region. Specifically, our problem was to model, first of all, cumulative effects in the Adriatic and Ionian regions within these tests for MSP. So we applied the source stressor endpoint model, which was firstly proposed by Alpern and colleagues. I'm sorry, the charge. By Alpern and colleagues in 2008. And sorry. Okay, by Alpern and colleagues. And basically the model is based on the fact that the human activities produce pressures on that impact environmental components. So the basis are environmental components and pressures and human activities. And we specifically elaborated the sensitivities on the environmental components on pressures through expert survey. But we had a problem. Because we modeled, and a challenge that we need to answer, because we modeled the cumulative effects for the specific geographical scope of the MSP, this implied that we had a list of uncertainties, among which the fact that data availability for the entire Adriatic and Ionian region was scattered. So we had a different knowledge and data available for the conservation features and for the human uses that we wanted to model. And the other aspect was that we had a completely different knowledge with respect to the cause-effect relationships, the pressure and impacts, so different confidence in assessing the sensitivity for the entire Adriatic and Ionian region. So how do we address this challenge, which was posed by specifically modeling the cumulative effect assessment for the purpose of informing MSP? We decided to model on one side the cumulative effects, so applying the Alpern model, the model of the stressor endpoint model, but also we tried to record all the uncertainty sources, so through an analysis of uncertainty, along with the process of with the modelers, with us, the modelers, the experts, and all the stakeholders that took part to the process and to the planning. So we arrived to to three types of the results. First of all, we identified the areas that were the most and least impacted. We identified also the availability of data to run this model. And we also assess the confidence on the sensitivities. And it is important that we mapped the confidence that we had with respect to different sensitivities. And this is very important because in MSP, one of the principles about MSP is the precautionary principle. So in ecosystem-based, you should be able to claim the precautionary principles, and the decision makers can claim the precautionary principles in case that three preliminary conditions are met. And these conditions are basically what we found with our results. So potentially the first condition is that potentially adverse effects are identified. The availability of scientific data is evaluated, so condition 2, and that the extent of scientific uncertainty is analyzed. Why is this important? Because of course, with MSP, we can act on the areas which are the most impacted to control and to limit and to reduce the impacts for potential uses and potential new uses in the areas. And on the other side, we can also identify, for instance, areas where impacts apparently are low, but where we know that with the knowledge is limited. For instance, the least impacted areas that we found were the deep sea areas in the Southern Adriatic and in the Ionian. And for us, this depends most from the fact that we were not able, and our confidence in the area was limited, as well as the data availability in this area. This is very important because a lot of time is the planning process that defines the scope of our models and not the other way around. Then we run also a sensitivity analysis to identify the uncertainties in the result of the model. So we run a Monte Carlo simulation under 50,000 of hypotheses. And in this image, in these maps that you see here, you see that the most impacted areas under the 95% of the hypotheses are in red. So what this is, it implies for MSP, it implies that here we are pretty sure, so we have a good knowledge that these areas are the most impacted, and we need to act, to prioritize and to act to reduce the conflicts and the potential negative effect there. But if we consider, for instance, the gray areas, and where, for instance, you might have high percentage of impact, but under, for instance, the 60% of hypothesis or the 40% of hypothesis. What does this mean? It means that we need here to monitor, to keep monitor, and to increase knowledge about the potential negative effects. And another important aspect is in the precautionary principle, the definition of its thresholds and the acceptability of risk is an eminent political decision. And so as a scientist, we need to show what are the potential implications on taking a certain level of risk and against another, and also related to the funds that then the plan should put in place to answer to specific risks that are need to be considered. So in this first part, I want to recap with answering to the question that I posed. So what is the ecological knowledge that we need to inform EBMSP? So first of all, it is a knowledge that is for the purpose of the planning. So we need to answer to specific planning demand. It's a knowledge that needs to be produced and to respond to the specific geographical scope of planning, at which so the objectives and the measures are designed. It is a knowledge that needs to be spatially explicit because we need to prioritize actions in space and time. We'll go back to time dimension in a few. And it's a knowledge that is to be specific of the areas to be managed. Of course, planning is based on the best available knowledge. So we plan with what we know and what we have, but it's important that along the planning process, we put in evidence what are the gaps and the knowledge requirements and knowledge needs and knowledge gaps that we need to fill in with the subsequent planning process, so that we can revise and adapt the plan as soon as new knowledge is available. So the second challenge that I want to discuss is related to climate change. So the MSP is going to be complicated by the fact that climate change is taking place on the global ocean, on one ocean, with different dynamics and mechanisms. And not only the marine environment is going to change, but also MSP is going to reflect and should reflect on the changes related to the changing environment, and also how we will reflect and will use the marine resources. So anthropogenic climate change will produce a shift in the ocean conditions and ecosystem structure and functioning, so that will induce a change in marine ecosystem services. And so, as a consequence, in human activities that are based on these ecosystem services, marine spatial planning will be influenced by climate change, but we have another opportunity here to address the change induced by climate change and to adapt and to mitigate those changes with marine spatial planning. And specifically in this second part of my talk, I will focus on what ecological knowledge do we need to address climate change with marine spatial planning. Here I present another study that I led under the Marcon's cost action, and it's a joint effect of two working groups. In this study, we addressed the problem of understanding the combined effect of multiple local human stressors and climate change, because this is essential to inform decisions about the allocation of uses in the ocean with marine spatial planning. So our interest and my specific interest was to understand how cumulative effect assessment have addressed the combined effect of climate change and other local human stressors. because first of all, I want to distill the major patterns of the ecological response, the combined response of the marine environment. But also, I wanted to investigate the response variables and the different methodologies that was applied to study the combined effect of climate change and local human stressors, considering several biases and several limitations from the model that we used, for instance, in the Adriatic and Ionian region. So, because the basic knowledge, the basic assumption of that model is that the single effects are basically additive, so are summed up, and this is a great assumption of this model. And moreover, this model has a problem on really responding to the functional dynamics in space and time. But beside the many other advantages of cumulative effect assessment as the Alpert model. So we ran a systematic review considering studies that addressed multiple stressors, multiple pressures, multiple drivers, so serious keywords with climate change. Because our interest was to reflect on how cumulative effect assessment and climate change can be used in MSP, we explicitly excluded experimental studies because we were interested in applying the combined effect of climate change and local stressor in natural conditions, and at the scales, again, the problem of scale at which the policy targets are designed and management takes place. So we arrived to 107 studies. So already the number of studies addressing these is quite limited, and this is very shaking, I would say. So we analyzed the results considering the level of biological diversity at which the studies were applied, so at species, trophic groups, habitat, and ecosystem levels. We considered the geographical locations and the scales at which the studies were performed and the method adopted exactly to explore the methods. We recorded the climate change drivers, considering the variables, parameters, and the models that were adopted. And we also recorded all the local human stressors that were modeled in combination with climate change. We used the word stressors because, again, terminology was a very big issue because there was not an homogeneous terminology. So sometimes stressors were addressed as pressures or generally as drivers of change or as human uses. The second problem in analyzing the result was that when we tried to record the ecological responses of the target features and the classification of the combined effect between climate change and local stressors, we found out that scientists and researchers used the terminology about the combined effect very inconsistently. Basically, there are a series of classifications that have been proposed in literature, but usually studies do not point which terminology and classification system they refer to. So to overcome this gap, we propose a simplified classification of the combined effect of climate change and local stressors in intensifying effects. So where when climate change basically intensified, amplified the local stressors, the effect of local stressors, mitigating, and the neutral effect of climate change and local stressors. So the first result that we found is that the knowledge is really scattered. So only few marine areas are studied with the intention of tearing apart the combined effect of climate change and local stressors. And this is a very risky point because actually MSP is on the move. In this study, led my friend and brilliant scientist from Portugal, Catarina Franz Santos, we found that 40%, almost 50% of the exclusive economic zones are going on the moves or are under MSP process, basically without knowledge, without being able to have the knowledge about the combined effect of climate change and local human stressor. And this is very risky because basically we risk that MSP is not able to incorporate or might amplify the effect of local human stressors driven by new human uses that can be allocated in our marine environment. The other important aspect is that we found several other studies, and I want to point out, for instance, species spatial distribution on statistical models or mechanistic models, or the combination of several models that were used to study the combined effect of climate change and local stressors. And the temporal scale was basically explanatory. So studies were meant to explain the past effect more than applied a scenario analysis. We recorded the 27 climate change variables and 52 local stressors with some groups of combination, and basically the most combination was that explained almost the 70% of the studies was between the industrial fishery and the change in temperature. The important result was that at species level, the climate change basically intensified the effect of local human stressor, while the studies observed a mixed effect at trophic groups and ecosystem levels. This determining it is important because it implies that climate change will potentially affect the response of ecosystems are basically context dependent, and it would be very important to study the interaction mechanisms and specifically the species role and the biotic interactions to address the propagation within the trophic chains. So some points for MSP. First of all, MSP can act locally to counteract the intensification of local human stressors. And this is already happening, for instance, in some studies related to fishery management and how fishery management can control the intensification of potential negative effects with climate change. Unfortunately, MSP in Europe, only UK and Sweden are actually incorporating climate change, not only as a general framework, but as in the planning measures to counteract climate change. So this is a very important point for the plans to come. Another important aspect for research is that the ability and reporting of the combined effect of climate change and local stressor depends on the study design and the related methods that has been used in the different studies. So again, I want to report the scale and of the type of knowledge that we need to inform decisions on within MSP. Because in the laboratory, we can carefully isolate the stressors and the effects, but there is a problem of scaling up and transferring what we can learn from the laboratory studies. So for instance, different combination of approaches can be useful, but also the intensification in the use of mesocosms is a good direction to overcome this challenge, but still there are problems of scaling up and transferring knowledge from experimental studies. Another problem is that for planning, it would be essential to understand the consequences of potential management action through the scenario analysis, because planning is majorly a forward-looking activities that try to anticipate conflicts for the future. And I'm going to...
No, Elena, siamo a 40 minuti.
Okay, I'm going to finish with the perspective of my Marie Curie, incorporating my Marie Curie is titled Marine Environmental Dynamics and Sex-Based Analysis for Climate Change Adaptation in Marine Spatial Planning. So the problem that I want to address with my Marie Curie is that basically MSP is mainly static, and it's basically focused on current situation at sea with difficulties in projecting visions and adapting to climate change. So I want to incorporate dynamic environmental changes with a specific perspective of sex-based analysis. So what is sex-based analysis? Sex-based analysis is a generic approach that has been proposed generically for all disciplines and science to lead discovery and innovation. So basically, sex-based analysis is an approach that empower discovery by analyzing the role of sex, not only in the term that we might conceive, for instance, in biology and in ecology, sex is usually used to determine intraspecific relationships, but also and specifically sex analysis is being applied in the way we set the research priorities, we define the research objectives, and we test the method that we apply in our research. So with a broader perspective. And with medics, I decided to apply this in marine sciences, and specifically in trying to understand how the response of marine organisms is mediated through sex-based factors. For instance, there is already evidence that climate change can influence sex determination of species. For instance, we know that change in temperature induce male-skewed fish populations and female-skewed population, and we know the sex ratio is a very important condition for population, for maintaining populations. But climate change can also differently affect marine organisms because of sex-based factors, or marine organisms can respond differently to climate change drivers because of sex-based factors. So already different strategies in the response of climate change were observed and stratified by sex, for instance, sex-based foraging strategies. So I applied this, and specifically the question that I posed with Marie Curie is, what if our models and our hypotheses in understanding the response of marine organisms to climate change were blind to these mechanisms? We risk basically to not get properly the response of marine organisms and to inform and to limit our capacity to inform decisions and to address this change in the future. So in my Marie Curie, I'm currently studying the effect of climate change, including sex, at different levels in the marine environment. This I will apply to model dynamically ecosystem service supply, including sex-based hypotheses. And then I will use this dynamic sex-based ecosystem service supply to explore strategies of adaptation and mitigation for MSP. So the results will come in the next 3 years. So if you want to stay tuned, just connect with the Twitter and so on, or emails. So why does this matter? Why is this sex-based analysis so important? Because in the new programming phase, so in Horizon Europe, we will be asked very likely to demonstrate how all the projects submitted to the Horizon Europe, whatever project, whatever topic, whatever discipline, responds to or apply or incorporate or respond to sex and gender dimension. We were already asked to do that for the Marie Curie, but this is very likely to happen. So be ready to answer to how your research assess the sex dimension if you work in ecology and biology, or in gender dimension if you work in social science. So as a final remarks, we have an opportunity, and MSP should be seen as an opportunity to work for conservation at specific scales of MSP, so a broader scale. This is very relevant for a lot of questions. MSP operates in a context of solving problems that needs a specific formulation. And so our knowledge needs to be able to answer to this specific formulation. So it is not just a matter of applying or applied science, but it is really a matter of formulating the hypotheses that are able to answer to specific needs. So I think about exploring connectivity, setting new marine protected areas. These are really, really challenges that need to be addressed at the proper scale. Our role as a scientist is to make trade-off explicit to inform decisions and to show the potential consequences of alternative planning actions with the knowledge. and also to be transparent about the purpose and the limits of our models, considering that, and I quote Professor Delev at Stanford University, that models are useful but not necessarily essential. So each decision problem will need a specific answer. So, and the last comment is about sex-based analysis, which is related to innovation and discovery. It is not related to just gender issues. So I would like to acknowledge all the research projects with which I finance my research and all the research collaborations, but I specifically, today is the day of women and girls in science, so I would like to acknowledge and a big thanks to all my women, female colleagues, my mentors and my PhD students and students I worked with along these years. So thanks all of you. And thanks for listening, and I'm open to questions.
Thank you very much, Elena, for this very interesting, complex, and question-generating seminar that gave an overview of a field of which we don't speak too often. So if someone in getting Elena's email, this is in the seminar invitation that you received. Please write your question in the chat. And this reminds me that these seminars are a formidable opportunity for the new arrival in ISMAR to get themselves and their research known to colleagues. So we encourage everyone who's just arrived to present a seminar on the previous research and on the future research. So now I close the record.
Okay.